Today we're learning our first theorem. You might have learned some topics like this last year in AP Pre-Calculus where there was like words instead of a formula. It's like a sentence that you had to know. We're not quite as picky about exact sentence structure per se, but you have to have the same meaning when you're using your examples and working things out. You have to show clear meaning when you're using theorems. So this is the first of, we'll only do maybe like 6 the whole year. This is our first one. It's called the sandwich theorem or the squeeze theorem. So in the sandwich theorem or squeeze theorem, you're given in the directions that you have 3 functions. So f, h, and g. So this one is the smallest and this one is the biggest. And then h is in the middle. So when we say like smallest and biggest and middle, like what does that mean? That means all of the y values on this are the smallest y values. All of these are in between the other, and all of the y values on here are bigger than the other functions. So here's an example of a picture. So the green line, all of those y values are lower. The blue line, all of those y values are in the middle, and the red line, all of those y values are bigger than the other functions. So that inequality is showing you kind of like small, medium, large y values of functions. So sandwich theorem says if you have this relationship on an open interval containing C, okay, so C is a number where you take the limit at. So if you take the limit of the smallest one and you take the limit of the biggest one, and they give you the same y value, remember limit's a y value. So if you get the same y value for the smallest and biggest, that means that the one in the middle will have that same limit because it's in the middle. So if the small function has a limit of L and the big function has a limit of L, then the function in the middle would also then have to have a limit of L because it's in between the other 2 functions. And again, that's what this picture is showing. So like f of x, as I come from both sides, whoops, sorry, the y value there is L. And then on g of x for both sides, the y value is L. And since h of x is in between there, its y value also will be L. And then this is just kind of like, in other words, another way to say it. So if f and g have the same limit, h must also have the same limit because it's between f and g. Look, if your outside functions have the same limit, your inside one has the same limit. It's sandwiched in the middle. Okay, so I'm going to work through 3 or 4 examples with you so you can see the different types of ways you'll be asked about the sandwich theorem. Like I said, there's 5 or 6 different theorems that you'll learn this year. I will say this one shows up more on multiple choice than free response, but not 100% of the time. So the good news is, as long as you understand what it means, a lot of times you don't have to worry as much about notation because it's a multiple choice question, but we're gonna do proper notation just to practice. Okay, so directions say, find the limit of f of x as x goes to c if c equals 0. And, oh, there's a typo here, sorry. Will you please add in the equal to? Sorry about that. So in the directions, we're told that f of x is the middle function. So this one has y values that are all below. This one has y values that are all above. And then f of x is some unknown equation in the middle. So you got like a quadratic open down, a quadratic open up, and something in the middle. So if I have this inequality, that gives me a clue that I might be doing the sandwich or the squeeze theorem. And I'm asked about a limit of the middle function. I don't even have an equation for the middle function, but I do have equations for the smaller and biggest. And I'm going to check the limit on each of those. And so we're going to practice using good notation. By the way, this is c equals 0. So limit as x goes to 0. I'm going to do that twice. Once on the small function, and then once on the biggest function. Thankfully, these limit questions within the squeeze theorem are usually pretty easy. Like I'm not doing a conjugate or anything. I just get to directly substitute in my 0 and I get 4 for both of them. Okay, so if the limit of this one is 4 and the limit of this one is 4, then the one in the middle must also have a limit of 4. So I want to show that because of this information, so I'm going to put the word therefore. The limit as x goes to 0 of f of x also equals 4. And so you don't have to use like the exact wording per se of the theorem. You have to understand what it means and then be able to get your math to show that meaning. And that meaning was that like, okay, these two both had the same limit, so the middle one has the same limit. Now, something where you would get where, like, let's say it doesn't work. Like, let's say this limit is 4 and this limit is 5, then you would have no way of knowing that middle limit. The only way this theorem works is if both of these come out to be the same thing, which they did in this case, so the middle one's 4. But when you do your delta math practice today, some of them won't come out to be the same. And so your answer will be like, cannot be determined. I don't know what the other number is. It's between 4 and 5, but you don't know what the number is. So you're looking to get those numbers to match. Okay, second example. Okay, so this is kind of one of those where there's no numbers in this question. It's all letters. We're math and reason, all letters. So the symbols get a little crazy, but it's still the same process. So first of all, we're doing the limit as x goes to a. So start out with limit as x goes to a. Okay, and then my function over here, this is an absolute value function, shifted right a, reflected, and then shifted up b. And then this one's absolute value function shifted right a, up b. So we've got like a v shape and a v shape. And then some function in the middle. So I want to take the limit of this small one. I'm sorry. Okay, so my limit of the small one, so b minus absolute value x minus a. My direct substitution means I put a in place of the x, because x is our variable there. I get b minus a minus a. And of course, a minus a is 0. So this limit overall comes out to be b, like whatever the vertical shift is. And then on the bigger function, I have b plus absolute value x minus a. And then I do my direct substitution there, and I get b plus absolute value a minus a. Of course, that part goes to 0, and I get b again. And since those are the same value, my middle function will have a limit that is the same value. Yes, question.
When plugging it in an assignment, do we like have to show the whole thing being plugged in and how it's worked out? Or do you just drop a little arrow and show the
When you say draw the, like this right here, like draw the
Yeah.
little arrow, I would,
just put the answer?
you're saying, could you do this and then go straight to B? Yeah, probably. Like, I don't need to see every single step, but I need to see enough steps that I can follow what you're doing. If you're doing that arrow, I can tell. Okay, questions on that one? Okay, so we're going to pause for 1 second. So I know I said I'd show you 3 or 4 examples. So I would say that this difficulty level, so to speak, on a scale of 1 to 10, we're sitting at maybe like a 2 or 3 here, for as difficult as these can get. Okay. Then delta math bumps it up a little bit. So it's like a little more difficult. And then we get to like really hard ones. And we're going to practice those. We're just going to like glimpse at that today. And we added one on here that's a real hard one. But I want to come back to this because this is like a level, I'd say 8 to 10. And this is like a level 2 to 3. So we're going to use delta math as like our middle ground. So hang tight with me 1 second. I'm just going to pull up delta math, the assignment you're going to do. You don't have to write anything down. I just want to show you what these will look like. Okay, so in delta math, they're going to give you a few different scenarios. And so a lot of times in the directions, you'll have 2 different equations. And then you'll have a limit. Okay? And so this limit is of a function I don't have given to me, but I do have g of x and h of x. So this is kind of a weird one to start on. I know they just generate problems randomly, but it's a weird one to start on, but I'll still show you. So limit as x goes to 1 and limit as x goes to 1 of g of x. If I directly substitute 1 in here, I get -4, -4 is -8, -3 is -11. Please check my simple math there. One agree? Okay, I'll plug 1 in here, -12 plus 1 is -11. So h of x is also -11. So it's very tempting. Doesn't it feel like f of x should also be -11? The only thing is, so this was an oddball one to get pulled up, is like, it doesn't tell you what the middle function is in the directions. So this one is gonna be, cannot be determined, because I don't know if this is the middle one, or that's the middle one, or f of x is the middle one, like, it doesn't tell me that in the direction. So let me generate a new one. Even though the two y values on this came out to be the same, I don't have anything that tells me the relationship between the three. So let me try a new one. Okay, so now this one will tell me what the middle one is. So to answer this, I would check the limit on this one and the limit on this one at 3 and see if I get the same y value. If I do, f of x has the same limit, be that same y value. If I don't, it's going to be cannot be determined. Do you understand what I'm saying by that, or do you want me to show that one worked out? You understand it? Okay, question.
Couldn't you figure out where it's like in the middle by looking at the range of functions given?
Okay, so the question is like, could you figure it out based on the function? Let's go. Can I go back to that previous question? Well, okay, this one's a linear and a quadratic. I mean, could you potentially? Yes, I suppose you could look at the range of the function, but it's not meant to be that deep. I understand what you're saying. But on that last one, we wouldn't know for sure, I guess, unless we went through and drew and did that. They're not expecting that. Yeah, I understand what you're saying. Yeah, you don't have to worry about drawing the functions out to visualize what's, just look and see if they give you the relationship in the directions like this right here. That's what you're looking for. If it doesn't give you that to establish small, medium, large, then you're not going to be able to tell. Or sometimes they'll give you the small and the medium and ask you about the large or something. Like you kind of look at that relationship of what the order is and go from there. So you'll have 5 of these delta math estimates. It will take you 8 minutes. So that's kind of like your middle range. And this is what I expect, or what I see from college boards. These will be the most similar to what you'll be asked on an AP exam scenario. That's forever away, I know, but this is more like what you'll see. Okay, back to notes then. So what does a really difficult, like level 9, level 10 question look like? And there is one like this on your worksheet that is due today. So if you want to have your notes out and then maybe your worksheet like right beside it, these are really similar. And you might be able to just get your worksheet problem done as we're doing this one. And then you'll just have that problem done.
Is this problem on our notes?
This problem is not on your notes. This is one we added in today because we were like, wait a minute, we're going from like level 4 to level 9 without a middle ground here. So we're adding one in to help us like make that jump. And do you know the worksheet I'm talking about? The one that's due today? It's like the limits. So it's on the back at the very bottom. And it says, use the squeeze theorem to evaluate. Yes. Okay. So your problem on your worksheet is different than this one. So, but I just want you to hold them like in tandem. And I want you to add this problem to your notes, please. I know there was an FRQ here. I think it's more helpful if you just want to like put it to the side of the FRQ and write this on your notes, like add it into your notes. And then we're going to do this one, but I think what I'm trying to say is like I think you can parallel and do the other one at the same time and just have it done. All right, so what makes a problem like a level 10 difficulty problem is if they do not give you the smaller and bigger function and you have to make it up yourself. So like notice we're supposed to have 3 functions like small, medium, large. But we don't have the small and the large one. We just have this middle one. And I have to create something that's smaller and bigger than that function. So here's how I want you to do this and the one on your homework. Focus just on the numerator, just this part. And I want you to visualize what that graph looks like. So this graph is the sine graph. So do this one along with me, and then I'll give you a second to try the worksheet one. Okay, so sine graph normally starts middle, high, middle, low, middle. That's my typical sine graph, but this negative flips that over. And then this one moves it up 1. So my 1, so this is just sine x. But 1 minus sine x is going to be flipped over and moved up. So it's going to look like this. Flip over, and move up 1. Okay, take a second, look at your homework question. Just focus on the numerator of that. Start out with the cosine graph. Flip it, move it up 2. So kind of like parallel, do that problem while we're doing this one. So back to our notes problem. The lowest y value on this graph is 0, and the highest value is 1. And that plays an important part because your graph then can be squeezed in the middle of 2 functions that are below 0 or above 1 or equal to. So I need to first come up with a number that's less than or equal to 0. And I'm going to suggest using -1. Honestly, you can pick any number you want, but I'm going to suggest using -1. So -1 is going to be my smallest number, just because that's below 0. And I could pick any number that's below 0. Then I need to pick any number that's 1 or higher. I'm going to go ahead and just use the number 1. So I'm picking a lower bound and an upper bound that's below my lowest number and above my highest number or equal. Okay, so on your cosine, did you have 1 and 3? You can just use the numbers 1 and 3 if you want. You don't have to do 0 or negative. Like you can just use those numbers. I don't want to use 0 because that works weird, but pick any number besides 0. Okay, so -1 and 1 are boundaries for this graph. The 1 minus sine x graph. So I know this inequality is true because of my knowledge of trigonometry and shifting the graph. I know that -1 is always below that graph. I know 1 is always above that graph. And that's focusing on the numerator. So then the way the denominator comes into play is I'm just going to be consistent about dividing by x plus 3 in all 3 places. And what I've created now is a function. This function is the smallest. This one's in the middle. This function is the biggest. Since I divided by the same thing in all 3 places, that inequality is still true. And you're going to do the same thing on the one on your homework. You have like your cosine function in the middle, but then divide by the same denominator in all 3 places. Now that I have an inequality, I'm going to take the limit on the smallest one and the limit on the biggest one. The limit as x goes to infinity of the smallest one. And then limit as x goes to infinity of the biggest one. And if I plug in infinity, I have -1 over infinity plus 3. And 1 over infinity plus 3. Infinity plus 3 is still just infinity because infinity is not a fixed number. It's an infinite amount. If I add 3 to it, it's still an infinite amount. Infinity represents a value without bound. So infinity plus 3 is still a value without bound. Okay, that's kind of like, well, what do I do with that? So, so the scenario I can think of, which is like easiest to think about, is let's say I have $1 in my pocket. $1. And I'm going to divide it up among everyone who lives on planet Earth. So like how many billion people live on Earth? A lot, right? Like I'm not going to say it's infinity, but it's a really, really big number. So if I take any fixed number, $1, and I divide it up among all of those people, how much will each person get? Like pretty much nothing, right? Like 0.000000001 or whatever. Like, so when you have a fixed number divided by an infinite value, the result of that is 0. So if you take one small number, divide it up into a ton of little pieces, your result works out to be really, really small pieces. So this will go to 0, and this will go to 0. So what does that mean about my middle function? It goes to 0. Yep. So as long as my smallest and biggest go to the same number, the middle one does also. So I'm gonna use an abbreviation. Have you ever seen this triangle to represent the word therefore? Then that's a universally accepted notation. So I'm gonna put therefore, the limit as x goes to infinity of the middle function is 0. So I want you to please try. So like in these next few minutes, try to parallel this same problem, but on your notes. So you're going to work with that, or not on your notes, I'm sorry, on that worksheet. Like this is in your notes. So on your worksheet, you're taking the cosine graph, figuring out the lowest and highest numbers, dividing everything by x plus 3, and then doing your limits of your smaller and bigger function to see if they both come out to be the same value.
So when you divide by 8, so you use that, is that like a generalization of it?
Yes. So we will, so like I'm not going to expect that you can do a level 10 problem yet on your own. Like I want you to try it right now. We're going to do more of these when we talk about infinite limits because we have not discussed this concept much, but yes, it is universally known and we'll like put that in writing in a couple days. So it looks like a rule. Okay, so take a second, please. Try to finish that problem out. What you're doing for the rest of class, let me end this recording. Hold on. Okay, what you're doing for the rest of class today is finishing that worksheet first. But before you turn it in,